In this video, we're going to talk about section 6.1, which is decimals and rational numbers. So let's first start with decimals. And to introduce that, we're going to introduce the concept of place value in association to decimals. So let me give like an exaggerated number for us to look at. I'm going to actually kind of draw it big too, just for the sake of labeling it clearly. So 432. 6, 7, 1, 5, 9, 8 with a decimal between the 2 and the 6. Okay, so we talked about place value, of course, when we started with whole numbers. So 2 is in what we call the ones place. I'm going to kind of do this diagonally. Ones place. 3 is in the tens place. 4 is in the hundreds place. Then we have the decimal, and after the decimal, we start mirroring what we have in front of the decimal, with the exception of the ones place never gets repeated. There's only one ones place. So 6 would be in the tenths place. And then 7 would be in the hundredths place. And we add the THS to emphasize that we are behind the decimal. I just realized I kind of wrote that funny. So here, let me give myself a little bit more room and write this number 1 a little bit more distinctly. So it's a 5, a 9, and an 8. Okay, there we go. So 1, I mean, if we were to keep going the other direction, in front of the decimal, we'd have had the thousands. So now we are at the thousandths place. Oops, sorry. When I bump the screen, and it's kind of hard to write hovering over the screen like this, it makes it hard for me to write. Okay. And then we go to, hundreds, thousands, 10 thousandths. And then 100 thousandths. I need to give myself even more room. And then last 8 is in the millionths place. And I hope we get the pattern. Okay, cool. So keeps going in both directions based on how many numbers we add. Leave a little space between this and what we're about to talk about. So just kind of leave a little bit of space there. When we introduce place value, that allows us to start looking at a couple different things, actually 3 different things. First, we can look at how we write the numbers in words. So write in words. Okay, so for instance, the number 16.14. We're not going to write it in words that way. We would start by writing in front of the decimal that number. So that would be 16. And then we represent the decimal with the word and. 16 and now we write the number after the decimal, which in this case would be 14. And then we indicate where the last digit on the decimal is by placing the place value, or I'm sorry, by mentioning the place value. So in this case, 4 on the 14 happens to be in the hundredths place. So I'm going to say 16 and 14 hundredths. The reason we have to do that, indicate the place value, is because with decimals, we can have a bunch of zeros before we even have a number, especially in like science. So let me give an example of where it's useful to have that place value. So let's say we want to do point, and then we're going to do 3 decimals, 0, 0, 0, and then 5, 1. Okay, so first thing I do is I don't have any numbers in front of the decimal, so I'm not gonna put anything there. I don't have to put the word and either, because there's no number in front of the decimal. So the thing that's going to indicate to somebody that what I'm writing is a decimal is the place value and the THS at the end. Okay, so first of all, when I want to say the number, that's the number 51. And then 51, let's see, it's going to be in which place value. So that's tenths, hundredths, thousandths, 10,000s, 100,000ths. Okay, so I'm going to put 51 100,000ths. And what that says then is that there's a bunch of zeros in this decimal, and therefore they have to, in order to make sure it's in the 100,000ths place, they need to go ahead. Sorry, it's like frozen for a second. I'm going to give it a moment while it unfreezes. And eventually it will. And then we put that 100,000ths in there so that, sorry, so that it is indicating where we need to make sure to have the last number landing in our decimal. Okay, so there is how we write that in words. The second thing is expanded notation. Okay, so for expanded notation, we also have to connect the ideas of place value to fractions. And now I'm going to come back up to this number, and I'm going to write each of these as a fraction. So when you say tenths, we should be thinking of the fraction 1/10. Hundredths would be 1/100. Thousandths is 1/1,000. And then 10,000ths and so forth, okay? I'm going to have to like connect them with a line because of space. This is 1/100,000 and 1/1,000,000. There we go. Okay. So we're connecting it to the fraction version of the numbers in expanded notation. Now, there are a couple ways to do expanded notation. There's actually more than a couple, but a couple I'd say that's the most common. So let's say, for instance, I wanted to write 0.047 in expanded notation. For a moment, though, I want to pause, and I would like to write this in words, since we just kind of talked about it in words, and let's practice that for a second. So if you want to pause the video and write it in words, that's great. But written in words, it would be the number 47. And 7 would be in the thousands place, so 47 thousandths. And there we go. That's how we'd write that in words. Okay, in expanded notation, what we would do is one version is to write it as 4 over the hundreds place, because 4 is in the hundreds place, plus 7 in, wow, got crazy with the line, 7/1,000. And that would be one way to write it. The book, however, likes to write it this way. The book writes it 4 times 100 plus 7 times 1,000. They like to write it with the times notation. In parentheses too, like they don't even use the little the cross symbol. So that's how the book kind of likes to express the expanded notation. Wow, I'm so sorry. I just dropped my calculator and it made quite a noise because it hit the wall. Okay, let's do another one just so that we feel good about it, since I'm making so much noise here. 3.06. All right. I'd encourage you to write it in words really quick. All right, just to practice. To write this in words, we would write the number 3 and 6/100ths. To write this in expanded notation, since 3 is in the ones place, we would write 3 times 1 plus, and then I'll just skip over to the 6 times 1/100. You don't have to put zeros in for any missing terms. That's fine. I believe we saw that when we did expanded notation with numbers before, where I mentioned even then you didn't have to put the zeros. It's okay if you do, but it's so unnecessary. So I definitely encourage you to skip it. Okay, so this time I'm just going to jump right to the expanded notation. 16.14, write that in expanded notation. So 1 is in the tens place. 6 is in the ones place. 1 is in the tenths place. 4 is in the hundredths place. And I do want to mention that what's nice about expanded notation is it, first of all, of course, reinforces place value, but it also reinforces the idea that we have these kind of reciprocal values here for like the tens and the tenths, right? That 1/10 is actually a reciprocal of 10. So it kind of emphasizes that reciprocal idea as well. Okay, then the last thing they really kind of play with is rounding. The rule for rounding is kind of annoying. I'm going to kind of abbreviate writing it out, okay? But the book has it written out very nicely, and I encourage you to kind of read through that if for some reason you've forgotten your rounding since we've done it, the last time. So you locate, and the reason I'm making a note of this is with decimals, there is one change. Okay, so you locate the digit in the place value that you're rounding to and look at the number to the right. Okay, if that number is 5 or bigger, you round up and the rest of the numbers disappear. And the rest of the numbers are gone. And then if it's 4 or less, leave it and drop the rest of the numbers. So they make a point of mentioning with decimals, we don't write any of the zeros following the decimal any longer. Okay. So here, let's just do a couple examples to feel good about it. Let's say we want to round. Actually, I mean, just do one example. Let's round 0.15789 round to the hundredths place. That's an S. I didn't actually make it look more like an S. There we go. Round to the hundredths place. Okay, so the number in the hundredths place is 5. So I'm looking at the number to the right of 5. Since it's 7, I'm going to round the number up 0.16, and then I'm not going to put zeros after that because 0.16 with all the zeros following is the same as just 0.16. And that's the big exciting thing with the rounding. So they do make a mention of that in the book. All right. Now I want to kind of look at how we do visualizing for fractions. Or I'm sorry, decimals, which I think they call modeling. I feel like I've been using the phrase visualizing, so I'm just going to stick with that. Okay, so the first thing is they kind of actually do a bit of a throwback to decimal squares, which throws back to what we did when we first introduced the numbers. So a decimal square, do my best to actually draw a square here. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this decimal square would represent tenths. Number in the tenths place. And then, of course, just like the others, we would also have 100. Okay. And the other way. Now, I want to mention that the publisher does have like a decimal squares sheet that you can use if you're going to write out your homework and you'd like a pre-printed sheet. And I'll post that on Canvas for you that you will be welcome to use if you would like, instead of drawing it out, which can be kind of annoying. All right. So yeah, if you want to use that, you can. So this represents hundredths. Cool. All right. Let's do a couple visualizations. Let's say we want to draw out 0.35. Of course, we're going to have to use the hundredths to do it, simply because 5 is in the hundredths place. Sorry, I'm going to kind of make it just a little bit bigger. Okay. Okay, I think I got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, all right. 9 lines gives me 10 divisions. All right. I'm always trying to visualize getting the center one relatively in the center when I'm doing the fifths. All right, there we go. Best I can do. Okay, so 35 means I'm going to shade first column, second column, third column, and then halfway on the fourth column. And there we go, 0.35. Okay, so I'm not going to make us do a bunch of these because we did do this kind of idea when we talked about the whole numbers previously. But I will mention where it's useful and kind of show an example of that. Okay, so it's useful for decimal equality and inequality. So it's useful when you want to show that two decimals are equal, or maybe which decimal would be bigger. Okay, so here, let's just do an example, 0.4, and we want to compare that to 0.40. Okay, so 0.4, we can use the tenths. All right, and I would be shading 4 of them. I meant to do it in a different color, but I'm not going to stress about it right now because they're so annoying. And 0.40, I would be using the hundredths and showing that 40 of them are shaded. And maybe you even paused the video and went ahead and printed off the sheet so you didn't have to draw these. That's fine. 2, 3, 5. Wow, that was terrible. Sorry. The one right before it wasn't very good. Wow. All right. I'm just going to get over it. 1, 2. Oh, there we go. And we'd still shade the first 4 columns all the way because that's 40 squares shaded. So exciting. Cool. All right. So there we go. It allows us to show that these two are equal because they're exactly shading the same whole. And it starts to connect to fractions too, right there, right? Like I'm using that language part and whole. So it kind of also gives us that connection as well. Let's look at a fraction inequality one. Shading 0.40. Oops, I'm sorry. Yeah, no, sorry, 0.40 versus 0.04. Okay, so in that case, we'd be drawing, oh, sorry, this is 0.40, same thing. We'd be drawing 0.40 and comparing it to shading only 4 out of the 100. 40 versus 4. Oops. This would be 0.04. And here I'm comparing these two since I already got that one written down. I'm not going to redraw it just for the sake of time. Okay, so there you go. That allows us to also compare decimals so that we can see 40 is different than 04. Now, since we brought up decimal inequality, I do want to mention there is a way of checking without drawing that two decimals, which one is going to be bigger. They actually have a name for it in the book. And I'll write that down in just a second, but I want to kind of visual or verbally talk to you about it. So let's say we want to compare 0.503 versus the number 0.530. Okay, and I'm interested in trying to figure out which one's bigger. So a lot of the numbers are the same, but we start by literally comparing each place value one by one by one. So starting with the ones place, they both have 0. Starting with the tenths place, they both have 5. Now at the hundredths place, we have a difference. In this number here, we have a 0, whereas in the second number, we have a 3. Since 3 is bigger than 0, this number would be bigger. And there you go. The book calls this place value test for inequality. It's the place value test for inequality. And it's the idea that you take each number one by one in each place value and compare them one by one. Okay, so that's that. The last visualization we will do is the number line. So the number line still has the ability to allow us to compare, or I'm sorry, look at numbers. But because we'll be looking at decimals, that means we need to kind of view the number line a little bit zoomed in, maybe. Like, so if I wanted to draw 0.3 on the number line, what I'm going to need to do is, all right, let's say this is 0, and this is the number 1, and the number 2. So notice how I kind of zoomed in a bit on my number line here. I'm going to need to draw 10 little dashes in the first number here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1. Cool. And 0.3 is going to be 1, 2, 3 right here. And there you go. That's how you do it on the number line. You literally got to draw as many little spaces as you need. Obviously, it can be challenging on the number line when it gets beyond the tenths place, right? But that's how you could do it. So real quick, I want to do another example. Let's say 1.5. That's not so complicated. And in fact, I really probably don't need to do all those dashes to do 1.5. 0, let's do 1, 2. I'm going to give myself a 3 on this one. Okay. So 1.5 is going to be right in the middle of 1 and 2. But like, let's say I wanted to do 2.4. So here, I'll add 2.4. For that one, I'm going to need to go ahead and do 1, 2, 3, 4, 1, 2, 3, 4. And now I can place my decimal accurately. And that's how we can use the number line also to represent decimals.